Welcome to Listen, Learn, and Lead, our series of interviews with extraordinary leaders doing extraordinary things here at Naval Postgraduate School. Today, our topic is artificial intelligence. Much like nuclear energy, artificial intelligence has both pros and cons, as well as advantages and disadvantages. Technologies of AI are being used by adversaries of the United States to exploit massive data collection and machine learning to erase or surpass the United States in overall warfighting, national security, and strength and power. In the great powers competition, other countries are pouring resources into AI, and some have declared that whoever masters AI masters the world. And that is the world of competition in which we presently are in. Naval Postgraduate School is in a unique position to help. We have deep faculty expertise in AI, data science, and geopolitical strategy. We have 3,000 students with operational frontline experience anxious to devote their theses, their time, their research, and their capstone projects to solving some of the grand challenge problems that frankly are in this arena. We are close to Silicon Valley and can foster collaborations with our faculty and our students. We have field experimentation facilities for both undersea and on-land testing. We are positioned on the shores of the Pacific Ocean, where much of the future action is likely to take place. And now I would like to introduce our very fine panel today on this very interesting topic of AI. I would like to have them introduce themselves and a bit about their work here and how it does relate to the issues and the topics of artificial intelligence. Dr. Carlyle, first you.
Thank you. I'm Matt Carlyle. I am a professor and chair of the Operations Research Department at Naval Postgraduate School. And in our department, we house the statistics group, and we have a number of researchers who are doing work and teaching in the classroom the techniques of neural networks, data analysis and processing, and we have a very deep bench of people who have expertise in fields related to AI.
And Dr. Denning, please.
Hi, I'm Peter Denning. I'm a distinguished professor here at Postgraduate School. I just finished being chair of the computer science department, a job I had for 18 years until other people coveted the job. I've been in the computing field for over 55 years, and I've watched AI grow up from a little baby discipline many years ago, and it's been very prosperous in computer science and in our department. We have also a very deep bench in this topic, and I'm delighted to be able to work with them, and some of them every day of the year.
Thank you. Dr. Kolsch.
Thank you. Mathias Kolsch. I'm an associate professor in the computer science department, and I started doing computer vision back 20 years ago, also a long time ago, but computer vision is important for artificial intelligence because it kick-started the recent revolution, really. So I've been working in this field for a long time and also working closely with the Navy and other DoD entities. So I have seen this both in the academic sense. I've seen computer vision applied to DoD problems and work closely with the customers thereof. I think this is something that we should come back to later on. It is very important to see artificial intelligence not as a solution, but really as a tool that helps solutions. I am also the associate chair for research in the computer science department, and as such I see myself as a facilitator for artificial intelligence work and academic work to reach other audiences, to work with our sponsors, to collaborate with industry as well, which I think plays a very important role in artificial intelligence. Data is important, and industry has a lot of data, just like the DoD, so we need to bring lots of people to the same table. So as associate chair for research in the department, I hope to shape how research projects can influence and impact not only the students during their theses, but also our the commands that we're working with and provide some value to them.
Thank you. So you all have expertise in various areas of artificial intelligence. I'd like to have you engage in a conversation amongst yourselves. You're here as leaders in an interdisciplinary kind of environment with professionals as students who've come from someplace and they're going to someplace. Many of them have experience in this world, but they don't have the seasoned and in-depth abilities that you have in your context and content. So I'm curious, what is artificial intelligence, and what are all of the things from that you think is important for our students to know, and your work in it? So may I start with you, Dr. Denning, with that, please?
I have a general view of artificial intelligence as machines that are able to do human cognitive tasks, usually through some kind of simulation of those tasks. We don't require the machines to be intelligent, and in fact, over my long career as an engineer and builder of computers, I've come to appreciate that the machines are definitely not intelligent, even though they sometimes exhibit intelligent behaviors. For example, a machine that can recognize faces might be able to tell me a lot of people's different faces. I show them a face that says who they are. But it also turns out that in the current generation of these machines, we can do simple things like change a few pixels in the picture. And suddenly the machine will say that's somebody else, even though I'm saying that's still my mother. And so there's a lot of research going on around this, trying to figure out how to stabilize these machines, that they're really good at very narrow things that we call human cognitive tasks. Now these machines also depend, a lot of these machines depend on data to train the machines on how to do things. And so that's why we have the three areas. I kind of think of them as two areas with an overlap, but there's kind of like three related things. There's the AI area, which is all the machines and their capabilities. There's the data science area, which is how to collect the data and curate the data and use it when necessary to train machines. And then in the middle, there's a whole bunch of overlap, which is what we're specializing in here. But machine learning is in the middle. The machines use the data to learn cognitive tasks. So these two fields of data science and artificial intelligence are not the same field. They strongly overlap, and we have a lot of interest in what we can do together.
So Dr. Denning speaks a lot about the notion of cognitive intelligence and the notion of the human being. Dr. Kolsch, when you talk about things, I think you talk a lot about the sense, what the AI is doing, the remote sensing in your world, the cloud aspects of it. How does that relate to what Peter's doing here?
So that's a very interesting question. I have to go back to when the recent surge in interest in artificial intelligence began, which is with the deep learning approach. And that was really fueled by two key ingredients. One was faster machines, faster computing power that could tackle more and more complex problems. But the other very important piece of that equation is data. We suddenly had access to much more data than we did in the past. And we had access to labeled data, so data for which we knew what it meant, really. And the combination of those two enabled these deep learning algorithms to really achieve fantastic results that before, with human-crafted intelligence or programs that we tried to implement and replicate computer vision, or the human vision in that case, they were not able to achieve that. So it was really at that point when people realized that given the right amount of data, given the right machines that are flexible enough, malleable enough to learn on their own, and a vague enough description of what the human researcher wanted to find out with this, the machines were incredibly capable. Now, is this cognition, is this understanding of what the machine is doing? The computer probably has no idea that it's looking at a face, right? So that's what Dr. Denning was saying. The computer is really not very smart, but it can do a task very, very well. And it has learned intelligently how to do so.
So Dr. Carlyle,
Yes.
Cognition, facial recognition, data, and what all that means. Dr. Kolsch had talked a little bit about analytics. How does that fit into all this?
Well, so when you have all of this data that you have to process, you have to make some decisions about how you want to model it. You can't just tell the computer, hey, process this data and tell me what the answer is. You have to give it some shape. You have to tell it, here's the problem I'm trying to solve, and you have to frame it in terms of mathematics. When you build that mathematical model and decide what it's going to look like, and then when you tell the computer how you're going to process that data and turn it into a useful answer for you, whether it's tell me if that's a tank or not, or tell me what type of ship that is almost over the horizon, you have done some analytical work beforehand building a mathematical model, and then you have taken this massive amount of data possibly and put it through an algorithm, almost like a meat grinder that you've designed very carefully to give you the right kinds of answers that you need so that you can process it and so that you can make intelligent decisions. And that's what we think of as analytics.
Continuing the conversation about the analytics that precede setting up the machine, one of the things that the public face of AI is the machines learn by themselves. So you present the data to the machine and it learns to recognize all these faces, for example. But most people don't think there was a lot of work done before that to curate the data and get it into the form that the machine could actually usefully use to learn with. So the idea that machines that learn are going to replace algorithms and mathematical models is just wrong. We need both of them to make all this work.
Yeah, and the machines have to be told how they're going to process that data. They have to be given the framework. So there's a lot of work that goes into it, and that's where an analyst comes in and gives it that shape.
Yeah.
And that's where the expertise comes in.
So
I'd like actually to say something quickly to that as well. There's an acronym that often gets used, DRIP, data rich but information poor. So we have a lot of data, but it doesn't really by itself mean anything. And we cannot just apply AI to it and turn it into meaning or decision worthy information. The analyst actually plays a very important role. Their job is often 80% of the effort to curate the data, to turn it into something that the machine understands. That's why it's important that the analysts work closely with the experts in the artificial intelligence, but also the subject matter experts, that really everybody on the same table understands what the problem is, what the technology is, what the limits of the technology are, and very, very importantly also whether the results of the artificial intelligence, once they come out the other end, whether they mean anything, if they really are useful in the application domain.
So here at Naval Post Graduate School, we're talking about this a lot. And you have the faculty just do these wonderfully organic groups that have tremendous amount of work and research and discussion. Could you talk a little bit about CISER, what CISER means and what CISER is here at NPS?
Sure, I'll start that one. CISER is an acronym, CISER. It means Consortium for Intelligent Systems Education and Research. We really are a consortium. We have faculty from all over the campus as members. Right now, our distribution list is 60 faculty in all 4 schools. And we are basically a conversation space where they can all find out about each other and talk to each other. And one of the things CISER is trying to do is help them focus into grand challenge areas where they want to talk to each other and help deal with these very hard problems that the Navy and Marine Corps are facing.
You should mention your innovative lecture series.
Yeah.
Sorry.
No.
Yeah. So as part of the things we've hosted already, one of the first activities we did was we put together a course called Harnessing AI. It's available on a website. It's a public course. It consists of 20 lectures, 30 minutes apiece, by faculty experts from across the campus talking about different aspects of AI. So some of them talk about the kinds of AI machines that are out there. Another set of faculty talk about the kinds of applications that these machines are being put to. A third set of faculty are talking about the strategic and policy and ethical implications of all this technology in the geopolitical scene. So this is a very rich conversation space that we've got set up here. And I think that's where the big value comes from. The problems in AI are not just machine problems, they're not just data problems, they're also geopolitical problems, and we have everybody talking together on it.
So the data science and analytics group, which includes the OR department, computer science and information systems, is sort of a natural partner with CISER, and all the members have found a great space to have discussions in the CISER meetings, and the focus in the DSAG of processing data, curating data, making it ready for analysis, and then figuring out how to analyze it correctly is sort of a natural precursor to many of the questions that you would want to ask in the AI environment. You know, then what do we do with all this data, and what conclusions do we draw?
I want to follow on what Dr. Denning explained with a CISER group and your Harnessing Artificial Intelligence lecture series. That nicely showcases that we are very well prepared for future demands. The Joint AI Center, JAIC or JAIC as it's often called, currently got tasked with educating the AI workforce for the DoD. And they realized that this Harnessing AI lecture series was very well positioned to educate some of the archetypes, as they call it, for artificial intelligence. So this is currently in a pilot program, and they're very happy with being able to use what the faculty had recorded here in lectures.
Didn't they use some of the modules? I think it was about 6 modules in
About that, yes.
Yeah,
So
they took 6 modules and put them into the general course for the DoD.
you can actually view them as well. If you just search for Harnessing AI lecture series, the videos are all recorded and available to the public.
Excellent advertisement for that great series. I tell you, it was very popular here on campus.
Yeah.
We had standing room only for those courses and those classes, and people came with the lunches, but they came we had folks sitting on the steps of the auditorium, didn't we? It was really very exciting and just really very, very good. It was a terrific series. Dr. Kolsch and Dr. Carlyle, and actually also you, Dr. Denning, have used the word meaning in the course of this interview. I'm curious about what you mean about meaning in the context of AI and data analytics. So let me start with you, Dr. Carlyle. What does meaning mean to you?
Wow, the meaning of meaning. No, that's a really good question, because we sort of throw it out there, but in all the departments on this campus, everybody that I've ever talked to, one of the most important things that we try to convey to our students is learning how to ask the right questions. It's when you approach a difficult problem and you need to figure out how to solve it, figure out how to ask the right question, and then it will reveal the right techniques that you want to use, and it will help shape what the answer is supposed to look like. And when I think of the word meaning, usually my reflex is to say, that's when the system is engineered correctly to give you the answers to the question that you want to ask. And so if our artificial intelligence systems are giving us good support and allowing us to make good decisions, that means that it's really tapped into the meaning that we were looking for. A random data set, once we actually understand what's in there, shape it a little bit, and then let an AI algorithm work on it and give us some answers, it's giving that data set meaning because it's telling it how it's going to inform our decision making and how it's going to answer those questions that we posed.
Well, the meaning question is a very interesting question. We've struggled with this one in computer science for years, because on the one hand, the machines just process symbols with mechanical means, and the machines have no understanding what the symbols mean, and in fact, they're designed to not have any understanding of the symbols. And yet, when we look at what comes in and out of the machine, we say it means something. So the meaning is us telling stories about the symbols that we see written on paper or coming out of machines. And the stories usually tell us why we care about what the machine has done. But the machine doesn't do that, we do that. The machine triggers the meaning in us. The meaning is already there in us, and the machine is triggering it. But sometimes we confuse these things, especially in the popular press. We think the machine understands the meaning, and it doesn't. It's us who have to tell the machine or tell ourselves what meaning we're trying to get out of the machine.
So if I have data and I'm going through you, and I have data going through Dr. Carlyle, it could be the same data with different meaning.
Right.
Mm-hmm.
You
Absolutely.
know, I used to use the analogy of, I'd read the newspaper in the day and there would be the stock market page with all this data on it for the stocks, and I would understand what it means because I'm trying to invest. If I show the same page to my mother who doesn't care about investments, she doesn't, it just looks like gibberish to her. So the same symbols have meaning to me and no meaning to her.
So again, we'll go back to Dr. Kolsch here in a minute, but for both of you, there is a certain amount of analytical requirement here to understand what it's really telling you versus what you think is telling you in some ways, wouldn't you say?
Absolutely, and you have to be careful. And of course, when we try to do things in the scientific and engineering fields, when we document the work of the results of our work, we have to be very careful that we state the assumptions that we made. And when it comes to AI and some of these deeper analyses of data sets, I think it's incumbent upon us to also appreciate what preconceived notions we might have brought to this and what might have shaped the questions we asked. And so if, for instance, the topic of possible cultural biases, wherever you grew up or whatever your educational background was or whatever your other things that might have shaped you, might lead you to ask questions in a certain way. And scientists deal with this all the time when they put surveys together, when they conduct studies of populations of people. They have to be careful about that bias. I think in the artificial intelligence world, I think it is incumbent upon us to do that as well.
That is a very important point, Admiral. You mentioned earlier some of the dangers of artificial intelligence, and Dr. Carlyle, bias is one of those very dangerous ones. So bias can be in the data, bias can be also applied to the output. And the data scientist or artificial intelligence researcher, they bear a large responsibility to be ethical in a way, to present the correct results and the results that actually are meaningful in that sense. There's a simple example that explains why we cannot just take what the artificial intelligence or machine learning tells us as gospel in a way. So, for example, it might come back saying that there is a strong correlation between living in the Beverly Hills zip code and income. But I must not interpret that as in I should be moving to Beverly Hills and will thereby boost my salary, right? There's no implied causation here. That is a very simple example, but there's many, many more very difficult to articulate dangers in a way where the machine learning, the artificial intelligence gives a very clear result, very high accuracy or whatever it is. But for the application domain, that might actually not be the right answer. That might actually point in the wrong direction.
So causation and correlation, that famous kind of,
Exactly.
of a comparison. But you also all talk about assumptions. And so there are human normative aspects to all this, aren't there? And so when there's a feeling that data will give you a better answer, that may or may not be the case, huh?
Yeah, that's absolutely right. I mean, there's so many opportunities to have bias just in the way you collected the data, and you just have to be very careful with that and make sure that if the things you're testing for and the questions that you're trying to answer, the data that you're collecting and the way that you're collecting it are going to allow you to answer those questions in a valid way.
So this gets to a topic that I would like to have all three of you talk about, and that's fully autonomous systems and what that means in AI. So you want to start with that, Dr. Carlyle, as to how this all fits into national security in our world, to the warfighting world, to the operational world, but what that means to us, and that is uniquely our obligation and what we understand about fully autonomous systems in AI.
Well, so in the public eye, fully autonomous systems sound really cool and very powerful, and having drones deliver your packages to your door and being able to make decisions and correct mid-flight and whatever. And you would think there are fantastic applications in the military as well. But on the military side, we have an obligation to make sure that we cannot fully automate major decisions. We cannot automate combat, for instance. We cannot automate anything that could have any kind of conflict involved because there always has to be a human in that decision-making process. So when we approach AI and we start figuring out what level of autonomy can we give our systems and what can we really authorize, we just have to be very careful that we know where that line is and exactly what is okay for us to automate and where we actually have to have humans in the loop and in that decision-making process.
So you talk a lot about this.
Yeah, this is an area of a very large dilemma that we face in the military. And I think a lot of people face it even if they're not in the military, to be honest with you. But on the one hand, you can have machines making decisions like driving your car or launching weapons, all on their own. When the right conditions come up, they fire, they steer, they do what they're going to do. On the other hand, we see these machines making serious mistakes. So we're still not ready to let a machine be a completely autonomous driver of a car because there's too many mistakes these things make. And similarly in the military domain, we're afraid that if we automate the weapon system, it'll take a decision that the commander doesn't want to take, but the commander has to bear responsibility for. That's the other side of the dilemma, is that you don't know what the adversary is going to do. Maybe the adversary isn't as ethical as we are, and they're going to automate their weapon systems. And so here we are trying to get the human in the loop to decide whether or not to fire, and they obliterate us in the meantime while we're thinking about it.
Yeah.
Okay?
Yep.
So that's the dilemma.
We've actually had autonomous systems for a very long time. For example, mail sorting machines are fully autonomous. They sort mail based on optical character recognition and slot them in the right outbox. But they all, as Dr. Carlyle said, have operating limits. They have a line at which point they will basically say, I cannot read this, and they will send it to a human. What people are afraid of now is that the autonomy is becoming capable to address more and more complex problems. And we don't understand so well anymore how it works. I think that is one of the big fears that we have. We cannot explain anymore what the algorithm really does. It's kind of a magic black box. Data in, some answer out. And there's a big research field dedicated to really finding out how these algorithms actually do the learning, how the representation happens of the problem inside the black box. And once we have a better understanding of that, then we, I think, will trust the systems more. We already know that they perform really, really well. There's examples of where they far outperform a human, again, within limits. So autonomy is there.
So this is a really interesting dilemma, and they are the kinds of questions that we talk about here and work with all the time. What are some other of these kinds of dilemmas, Peter?
Yeah, well, another one is we have a faculty member in the electrical engineering department named Will Williamson, who wrote an essay recently which won an essay contest. And my take on his essay is that he talks about the dilemma of the observable ocean. So what he says is that the networks of satellites with all the sensors they have and the high-speed communications that we now have, combined with machine learning, is making it possible for commercial entities to track the movement of every ship on the sea, whether it's a commercial ship or a military, anything. If it's moving on the sea, they'll be able to detect it and even tell you what course it's taking. This makes the sea completely visible to anybody. One of the old tactics of the Navy has always been to find places in the ocean where they could hide the fleet until it's too late for the adversary to react, and then the fleet is there. If you can't hide the fleet, how do you form strategies in the ocean?
And this is one of the great gifts of NPS, if I might say, is that we can consider grand strategy in the context of science and technology in a way that many people cannot. And so this is one of the attributes of NPS, is being able to do that. Some other dilemmas.
So another dilemma is that AI systems can provide so much information in support of decision making that it can actually overwhelm a single human to where they can't make a good decision because they can't process the information they're getting fast enough. I think, Peter, you were talking about this earlier.
Marines are very interested in this. They call it cognitive overload.
Yeah, cognitive overload.
And how can they function effectively in the field if they can't make sense of all the data and all the recommended decisions because they're coming too fast.
Yeah, which means that you then have to have people who understand human cognition, who understand the physiological and psychological aspects of processing all that information and turning it into something operationally relevant. You can't have Marines lock up on the battlefield because they're getting too much information. You need to give them the information they need so that they can make a good decision quickly.
So this is an interesting phenomenon, is that the more you use data, the more you need to have people who know how to use the data really well.
Yeah.
And so you need to have that human systems integration piece with the data integration.
There's a wonderful old example. The I Love Lucy show many years ago had a very famous episode called The Chocolate Factory.
The chocolate, yeah.
And it showed Lucy trying to wrap chocolates coming by on a conveyor belt. And her supervisor said she's being trained to wrap chocolate. So Lucy got good at it. Then the supervisor would come and say, "You're good at it, you have to do more of it. Increase productivity." So the conveyor belt goes faster, and Lucy goes a little faster. Then the conveyor belt goes even faster, and Lucy goes a little faster. And all of a sudden, the whole thing falls apart. And that's what happens with information overload. You seem to be going along okay, and then a little bit more speed of the stuff coming at you and you collapse, literally.
So the art of decision making is all part of this too, as to when and how and by what means you make the decisions based upon the information you're getting. So AI can move faster, so you assume that because it can move faster, it's smarter.
Right.
Speed is made to equal intelligence in some ways, and yet maybe that's not the case. It's a temporal bias in some ways. How do you talk about these things and the phenomenon, the dilemmas of decision making, of the human being in the middle of this, or should we all just go robotics and let the robots make those decisions? What are your views about this? Because these are the kinds of things that people ask all the time.
I think that's a very important aspect, and we will see more and more the quest after human-computer collaboration to rise to the forefront. We now understand how we make the computers work really well, but really computers are only there to help us out in a way. If we cannot efficiently, effectively interact with the computers and the computer with us, neither of us can reach basically the same pinnacle of performance. And some of the chess competitions also mirror that. If you pair a computer and a human, they can do much better than a computer can do by itself or a human can do by itself. So it's really this collaboration. And I think there lies a big promise also of artificial intelligence. Well, if AI becomes better and better at modeling how the human works, how the human processes data, well, if it can understand how we need to see that information, maybe the computer can kind of pre-process and form the data in a fashion that I needed at that very moment. So it can do it really fast, it can supply it to me at the right moment, in the right position, in the right environment, and it would be very beneficial.
So in AI, and I know that one of the aspects of AI is the more information you have, actually the better it is, because it self-refines and it self-governs, based upon patterns and anomalies and those kind of things. How do we think about AI as a pattern process rather than an anomaly process, and how does that come into the reasoning of AI, and as far as how it then gives us the information?
Well, I going back to what we said about meaning before. The word information is an assignment, an assumption that we make about data. The data contains information and gives it to us. But that, if you look at that carefully, that doesn't make any sense, because the data is just symbols. And information is really an assessment that an observer is making about the data, what it says to them. So this is a very tricky problem. How do you tell where that line is?
It's kind of like when I use GPS and it's telling me to go left, and I know that the right is the better answer.
So if you say the machine is giving me information, actually the machine is simply triggering you with symbols and signals, and you're interpreting them in a certain way, which you call information. The same thing can go to him, and he reacts in a different way to the same signals.
So you three are both teachers and researchers. And as we close up this interview, I would ask you, you're standing in front of a class and you are talking about AI, and you're talking to people who have been in leadership positions or will be, and leadership is very near and dear to their professional lives. How would you say to a leader what his or her ability will be as they continue in their professional lives and they think about AI? What do you want them as leaders to be thinking about in the entire phenomenon of AI and its applications? Who wants to go first on the issue of leadership and AI?
I would say that one of the big promises of AI is the ability to amplify human intelligence. So we can be smarter because we have advice coming to us from machines about possible decisions, but we still have to make the decisions. But the machines are doing a lot of processing for us, so we're able to be smarter. And if we can keep that in mind, as machines are tools that make us smarter, and I think that a lot of the promise of AI would get delivered that way. But we also, as we've been saying, have to deal with all these dilemmas that keep coming up, and dealing with those, because some of them are could be very costly if they fall the wrong way.
I think one of the messages that I would like to get across is that leadership in technical fields always requires questioning of the assumptions. And when people who have done analysis for you bring something and make a recommendation to you, in certain areas we know what kind of questions to ask. Where did you get the data from? How many people did you interview? How did you verify that this was correct? And the suggestion would be that if there are going to be artificial intelligence systems in that chain, bringing those decisions to you and making those recommendations, figure out how to ask questions about those assumptions and to talk to your analysts and figure out what did they do to get me this answer, and can I trust it? Do we feel like this is a solid decision, or is there still work to be done? As in any other technical field, I think those same basic principles apply in AI.
Those are some really good answers. What I would tell my students on top of that is that they need to be patient. Artificial intelligence is a new tool, and we cannot expect applying it to a new problem is going to work on the first go. And in fact, some of the best solutions that I've seen, they were just iterations over and over again. And that is, I think, one of the big benefits also of the Naval Postgraduate School, and how it brings subject matter experts and technological experts together in the same room. Some of my most successful thesis projects with students really did exactly that. We iterated many times and were able to change, for example, the data collection. So when the first results come out of the artificial intelligence or machine learning tool, you should see those as a beginning rather than the end. And then we need to change the way we collect the data. We need to talk back with the subject matter experts. If those are really the right questions, did we ask the right questions? So this all comes together, and the closer you have to people that understand all these aspects in the same room, be it a virtual room or a real room, the faster you're going to really synthesize solutions there.
So this panel has been very interesting in so many ways and very provocative. I think that what I am sitting here thinking about, though, is that we may have begun a new lunch series, brown bag series, when everybody's back on campus after the COVID period, and that is a series on the great dilemmas. Because these kinds of questions that you have been talking about today are what are confounding to not only our students at times, although they're looking for solutions and looking for real things to make things work, but also to the average citizen. So these are really important questions. And I think that we'll have to start brown bag series on the great dilemmas of our time. You've been terrific. You've been extremely intelligent, of course, and just wonderfully informative and provocative. Proud to be here with you today. We thank you for joining us in our Listen, Learn, and Lead series of talking with truly extraordinary leaders doing extraordinary work here at Naval Postgraduate School.